we're going to slightly shift over to four-sided, and anything, right? You're gonna need to know names of various shapes, right? So that, anybody know what we call that? It's a parallelogram, right? Parallelogram. You can look at your squares, your regular squares. So a square has all four sides the same. We're going to also deal with kites. Yeah, that is a shape actually. Yep. So we're going to deal with that. And then last but not least, we're going to start talking about polygons. This is where we're going to spend the majority of our time in the polygons section. So that's where you have your pentagon. You're all familiar with the pentagon, right? It's a shape, but it's also a building in the States, right? Famous building, the Pentagon. And then you have your stop sign. How many sides does a stop sign have? 8, yes. Octagon, pentagon. But it also includes everything we've learned up until this point, right? Triangles, rectangles. It just includes everything. So when you talk polygons, it's all of the shapes combined. Can I just add here a four-sided shape, or four-sided shapes are called quadrilaterals. Quadrilaterals, right? So there you have it. That's the main idea of this, and then a lot of stuff in between, of course. So let me just use this section down here to review Pythagorean theorem. I know you know how to work it, but some of you need a review, and I will also do it. I will use a shortcut. Okay, so when you look at this triangle and there's a 90-degree, you can use Pythagorean theorem. What do we call the side across from that 90? Yes. Write this down. Doesn't hurt, right? Hypotenuse. And the other two sides are called? We call them collectively legs. This is a leg, and this is the other leg. I like to think of, there's your hypotenuse, which is across the 90, it's the longest side, and then you have your two legs there. So there are two scenarios. Watch this. If you're missing the hypotenuse, if the hypotenuse is unknown, right, we're going to do it a certain way and just cut it a little bit. The other one will be the scenario where you're missing a leg, right? You're missing a leg. That would be this scenario here. We all know, or at least should know, right? Hypotenuse squared is equal to leg squared plus leg squared. Right? This squared is equal to the sum of the squares of the legs. Therefore, the hypotenuse, just the hypotenuse, will be the square root of leg squared plus leg squared. Okay? So I'm going to actually always go straight to this equation right here. So the hypotenuse, if you're into highlighting, right? If you want to know what that is, then there it is, right? That's your unknown. That's how you. And then the key here is you will be adding, right? But what if it's on the other side? If you're missing one of the legs, if you're missing one of these sides, it's going to be like this. Leg squared is equal to hypotenuse squared minus the other leg squared. And therefore, to just get the length of the leg, you're just going to have to square root the hypotenuse squared minus the leg squared. Okay. So either one of these, what's the big difference here? Do you notice that there's a subtract, right? When you know the hypotenuse and one of the other legs is subtracted from the hypotenuse, and where you go. And so I will also add this. Only works with right triangles, right? In a sense, you must have, right? You must have that 90 degree somewhere. Okay? You need 2 out of 3 sides. And this should be in a cloud like this, just as a reminder. Only works with right triangles. No surprises. You've seen this Pythagorean theorem minimum, like the earliest you should have, or the latest you should have seen that is grade 9, right? Probably earlier than that. But here you have it one more time. If you're missing the hypotenuse, just square the legs and add them. If you're missing one of the legs, just take that, right? You always have to square them and then either add or subtract. Basically what it comes down to. Let's put this to practice. I need you to know how to do this quickly. That's why I'm giving you a shortcut there. I know that some in previous years you probably always use the generic formula and then just isolate it. Make sure you follow along, right? Follow. This I'm gonna ask you to scratch to just take this off. We're not gonna use SOHCAHTOA. You can, but you might run into issues. So we're just gonna not worry about following SOHCAHTOA. So here, calculate the length of the missing side. Okay, so we have, it's a right triangle. Do this quick. Right triangle, check. 2 out of 3 sides, check. I know 2 out of the 3 sides. Okay. Can you do me a favor? Label your hypotenuse first. Know which one is your hypotenuse. Find the 90 degree. Everybody, yeah? Cross, this is your hypotenuse. So that's what's missing here. So we're going to say, hey, to find, let's go leg and leg here. Right? So to find the hypotenuse, we're simply going to square and add the lengths of each of those legs. That's all you need to do. That's how fast it is. And then I want you to show the intermediate step. A lot of you will go straight to the answer. Please don't do it. You want to write this part down here. Square root of 146, because you figure out what this is first, and then square root that answer. So it's 12.09. Yeah, centimeters, thank you. There we go. Could you have used the cosine law here? Side, angle, side. Yes, you would have the exact same answer. Cosine, you know what cosine of 90 is? Oh, how do you know? You tried it? It's actually 0. Sine of 90 is 1, cosine of 0. It's a long story. I'm not going to get into it. But there we go. All right. On this page, go to 176. I just want to make sure you know how to do Pythagorean theorem. That's all I need. I need to make sure you know how to do it before we move on. So try those 3 questions, A, B, and C, real quick. Notice C has 2 triangles, right? Start with the one that has the most information. And I'll come back, see if yours matches mine. Oh, I said I'm not going to do that anymore, right? So straight to square root. This is a missing leg, right? So always hypotenuse first, minus there we go. Two steps. Start here, then go over there. For this one, this is a leg here. I'm going to call that X for now. Hypotenuse minus leg. Then I move over to this one. First triangle, second triangle. P is the hypotenuse. So it's 57,7208 squared plus there we go. That's what it should be. So if you matched my answers, if you were able to do it, you're good to go. But that's not what today is all about. This is just a review. Because we're going to have to figure out quickly what the other sides measure, okay? So follow me to, I'm going to skip a few pages here to get to today's section. So I'm going to ask you to go to 179. And if you have a highlighter, this is where you should probably take out at least one color if you can. So I'm going to ask you to add a heading here, nice and big, okay? So I'm going to ask you to, on this page, you write down classifying triangles. Right? So this is on 179. On page 179, we went to 179 real quick. And just write down classifying triangles. So I think the characteristics are very straightforward, right? What properties describe a triangle has three sides? Closed figure. These are all things that are very particular to a triangle. The sum of interior angles is 180. No surprises there. This is what I want you to focus on. That triangles, you can classify triangles by the side length or by the interior angles. Okay? Two ways to classify. What does classifying mean? Here, I'm going to go arrow out. It means naming them. They'll have a first and a last name. Every single triangle in this unit, it actually always has a first and a last name, but we just didn't bother doing that until now, and that's what today's all about. So highlight this part, the whole box, because to me, this should be on your study sheet. Not quite as big as this, but this section should be in there. So if you want to classify something by angle, there's three choices here: acute, right, or obtuse. Okay, so what does obtuse mean? The angle is greater than 90, exactly 90, less than 90, right? That's how you make your statements there. That's how you figure out which category it fits into. So you can only be in one of these three at any given. This is the first name. That's just my own thing. That's the first name of a triangle. And then the last name we'll go over to the second page, to the page right after this. Just follow me here. This is what I call the last name. Okay? Last name of a triangle. Highlight the whole thing. Because when you flip through it, come exam time, you know, okay, I remember this was important. This is different. So you have three categories here when it comes to side length. Equilateral, three sides are equal and three angles are equal. What do the angles always measure? How do you know for sure it's an equilateral triangle? Yep, so that would be one giveaway, and the other giveaway would be if all three angles are equal, so that's 60 degrees. Angles are 60. So is there such a thing as an obtuse equilateral triangle? Think about it. If it's always 60, all angles are less than 90, right? There's no such thing as an obtuse. So you knowing that it's equilateral tells you two things. Obviously, it's equilateral, all sides are the same, and that all angles are less than 90. So can I just go back for 1 second? I feel like there's enough space to do this here. To 179, go to the bottom of 179, and you'll do this and this. Okay? First name, last name. First name, last name. Do that at the bottom. So the first name, you'll have three options. And it's acute, right, and obtuse. You know what? If you just put this on your study sheet instead of that whole chart, just this bottom here for this chapter, that's going to be plenty. So for last name, you have equilateral. You have isosceles. And you have, what's the other one called? Have you ever heard that one? Scalene. Have you ever heard of that? All angles, all sides are different. Did you know? I talked about the relationship, guys. Make sure you understand this. If all angles are the same in a triangle, all sides will be the same. If two angles are the same, how many equal sides will you have? Two. And if they're all different, then all three angles will be different, all three sides will be different. So every triangle has a first and a last name. How's that? And I'll walk you through it. How are we going to do that? Well, we need to figure out some information in order to do that. So follow me now. Let's do this. Let's actually put this into practice. Okay? So I'm going to go. There's a blank page on 181. That's the first thing I'm going to do here before we do anything else. Nice and easy. I'm going to ease you into this. So this is on page 181. Everybody follow, right? Classify. 181, yeah. Classify the following triangles. And you're going to have to copy stuff down here. Classify the following triangles, right? So let's do one at a time. So let's say you see something like this. Maybe let me draw it first and then you copy it. You have that one. Let's do B right underneath. Oh, I messed this up a bit. Let's try this again. Okay, so those are the 3 on the left, and then I'm going to try to get another 3 in here. There's a 60-degree in there. I kind of messed this up. Sorry. What's happening? I think they increased gravity over the weekend. Turned up the gravity knob. So let's try this again. There we go. There. So copy them down before I start, because I'm gonna use if you have a blue pen or a red pen, anything that I add, I will do that in a different color. Okay. Okay. We're getting somewhere. We're getting closer to the end, right? We're moving along, so let's keep that up. All right. Here, classify the following triangles. So in this particular case, you want to come up with the first and last thing. The first thing is, by the way, it doesn't matter if you mix them up. If you first give me the sides and then you give me the angle, it's okay, right? But let me have this up here, okay? If it goes by angle, so you have this on your study sheet, right? Which one would fit? Do you know this one right off the bat? There's a right triangle, so that's a dead giveaway. So this is a right. So that's the first name. And what's the last name? Scalene. For this, I think you should add something to your notes. Equilateral, you should say, can I add that to yours? I think that would be good for you to have. Sorry, now it's all sideways. You're like, I can't see that. So if you go back, I know I'm jumping a little bit, but I want to help you out. That's why I'm doing that. If you go here, go back to page 179, right? Equilateral, all sides and all angles are equal. Okay? All sides, all angles are equal for equilateral. What about isosceles? Two sides, two angles are equal. So all three, in this equilateral, 3 and 3. 3 angles, 3 sides are equal. Isosceles, 2 sides, 2 angles are equal. Scalene, no side, no angle. Angles, right, are equal. No sides, no angles are equal. Okay. I want to help you out. That's why I'm doing this. So if you already knew this, all good, no problem. We keep going, right? I just want to help you out. I want you to have something on your study sheet, not just for tomorrow, not just for next week. I want you to have something on your study sheet that on the exam, classify this one, Oh, right here, boom, right? I know how to do it. Study sheet, right? Okay, let's go back here. Classify the following. So we're going back to 181. Sorry for the jumping back and forth here on you. But it's a right triangle because of this. And what about the side length? We have no numbers here. But these markings tell you that they're all different. So this is as scalene. And that's because of the markings. Okay. Next, B. What can we do here? It's a right, okay. Let's do that right away. Right, and that's because of this angle. I'm gonna go because of that angle. Okay. And what about the side lengths? It's an isosceles, okay. Two sides are the same. So that means, watch out carefully, guys, because I will actually go overkill here just to make sure I'm getting this right. These two angles are the same, correct? Because these two sides match up with the angles. How could I find these angles? Is there a way? I'm going to go 180 divided by 2. That's right, because if you take the 90 away from 180, right, and then you split what's left in 2, then you split that exactly amongst these two angles. So that's 90 divided by 2, which is 45 degrees. Okay, so this is 45, and this is 45, just in case, right? But this is still a right isosceles. Right isosceles triangle. Okay? That's how you would label that. C, what is that? This definitely looks obtuse. So write that down. Obtuse is the first name. All sides are different. Scalene is the last name. It's an obtuse scalene triangle. Sometimes you're going to have to do some math. Other times it's just as plain as day. You just look at it. It's there, right? Let's keep going here. D. You have a 60 here. You need to figure out what the rest is. Watch carefully. These two sides are the same. So you travel across and you put the markings across those. So we're told that these two angles must be the same because of the sides, right? So what are we going to do here? 180 minus 60 divided by 2. So that is 120 divided by 2, which is 60. So now you figured out that this is 60 in this corner here, and this is 60 as well. What kind of triangle does that look like? Acute equilateral, yes. However, the acute is not necessarily a must. When it's equilateral, you can just say equilateral because it's definitely going to be acute every single time because it has to be 60 for it to be equilateral. Doesn't matter how big or small a triangle is, if all sides are the same, it's 60 degrees all across. What about this one? If these two sides are the same, watch carefully. That means that this side has a 25 across from it, right? What will the other angle be on the other side across from this side? It's like copying, right? Like you copy the same angle because if these two sides are the same, then this must be 25 on each side. So do we have partial information? Do we know one of the names? Definitely, we know that this is isosceles for sure, right? We just are investigating what is this angle up here. So to get that angle, we're going to go 180 minus 25 minus 25. And what is that? 25 and 25 is 50, right? Take away from 180. That's 130 degrees that you found. So what's the first name? Obtuse, because of that angle not bigger than 90. and isosceles is the last name. I can tell you love this unit already, right? But just, you know what? Just start finding stuff about it. Find angles if you can, find sides, and then make your decision, okay? Over here, if you look at this like, oh, these two sides are the same. So if this is 45, go to the other side, travel across, and copy that angle. It must be the same, guaranteed. And then you're figuring this kind of looks like a 90, right? You're just going to confirm that. To get this angle, we're going to go 180 minus 45 minus 45, right? 180 minus 90 essentially. So you're left with 90 degrees, right? Now you know that that's 90, okay? If you do work around the triangle, I'm okay with that, okay? So this is a what? A right. Two sides are the same, right? Isosceles. Let's do a couple more. I'm just thinking of scenarios here. Let's just do a G here. What if I did this? I'm thinking, just give me a little bit of time here. I'm making this up on the fly, okay? So I'm going to make this 15 inches. This is going to be 12. And this, no, I will make this 8. And this is going to be 11 inches. What if you had something like this and I asked you to classify this one? Did you learn something in the previous unit that could help you out here? Because there are no angles, correct? But let's fill in what we know. What all sides are different, correct? It's going to be a scalene. Scalene. Yeah, it's a scalene triangle, right? All sides are different. Have different lengths. Write that down. But what about the angle? Can you 100% tell me that this is either a right, an acute, or an obtuse? You can't tell, right? Which angle should you find to narrow this down? Across from the 15? So this one here. If we do this and we get a negative, then we know it's obtuse, right? Okay, so let's call this angle A. So let's investigate. Cosine, write this down. Cosine of A is going to be, what's the first thing you write down? Right, the plus or minus, but I will start with this side across the angle I'm interested in, and then the other two I square and add. Okay, and it's 2 times 8 times 11, like that. Let's plug this in. So that's 64 plus 121 minus 225. That's minus 40, okay? It's obtuse. I will still figure out what it is. Oh, sorry, I really got this one wrong. I typed in plus, there, 0, 227, keeps going. So angle A is cosine inverse of negative 0.227, keeps going. Angle A is 103, yeah. Therefore, now you can say, okay, I did all of this. Now I know for sure that this is an obtuse. Do you need to figure out the other angles? No, as soon as you have one greater than 90, this thing is automatically obtuse. Okay, no need to figure out anything else. So sine law, cosine law are very much present. Okay, so don't forget about that. Okay, I need you to go to your workbook because for some reason this book the notes, they do not have a whole lot of exercises on this topic. I want you to go and start on page 3. It says classifying triangles, right? So take your workbook and work from 3 to 5. Yeah, I'm going to hand them out as you're working. Page 3 to 5 in the workbook. Okay, hold on. There's something there. The answers are right. If you keep flipping through that workbook, you will see the answers. Just don't look at them just yet. Just try to figure out on your own, but they're right there. Just keep flipping and they classify it for you as well. Okay, so you have